All right, hey, in today's video, we're just going to be exploring the Pythagorean theorem a little bit more. And instead of actually having to find the missing side like we learned in the last video, we're actually going to be given all three sides, and we're going to figure out if it's a right triangle given the measure of the three sides. Now, I want to remind you guys that we have lots of different types of triangles. The one that we're exploring in this unit is, of course, the right triangle, and I'm pulling that up here. So we've got our right triangle. We have acute triangles, and then we also have our obtuse triangles. So if we have a right triangle, we know we have something called a squared plus b squared equals c squared, and that should give us a right triangle. And we're going to look a little bit today, if we're given the measurements, if they end up not forming a right triangle, how it might end up forming a little something that looks like this, okay? All right, so for the first one, we're just going to determine if these three lengths could form a right triangle or not. If not, we're going to sketch the triangle using the dimensions, okay? So for the first one, all I'm saying is if I give you three lengths of a triangle, 6, 8, and 10, my question is, would it be an obtuse, an acute, or a right triangle? Would 6, 8, 10 make one of these three triangles? Now, if it forms a right triangle, we know that the Pythagorean theorem should work. So we could ask ourselves if this side squared plus this side squared equals this side squared. And if it does, yes, we've got a right triangle. And if not, we have one of the other two types of triangles. All right, so for the first one, 6 squared, you guys know 6 squared is 36. We also know 8 squared is 64. And we're going to try to see if when we add these up, is it the same as the 100 we get over here? Now, when I add 36 and 64, that actually is 100. So since a squared plus b squared does equal c squared, I know I must have a right triangle. This is a yes. Okay? Since that's a true statement right there, yes, this would form a right triangle. And we can just briefly sketch it. If this side is a 6, the 8 needs to be a little bit more than that. And then the 10 would be the hypotenuse side right here. So that would be our right triangle. So yes, we have a right triangle here. All right, now let's look at the next one. So again, we have three lengths, and we're just going to see real quick, would this squared plus this squared equal this squared? One thing I want to mention briefly is that in my notes right here, I do have all the sides going from least to greatest. I could have put the 9, then the 7, then the 5, and expect you to realize that the biggest number would always be the hypotenuse. In any triangle, the longest side, the bigger number, is always going to be the hypotenuse. The other two, it wouldn't matter, but the biggest number is always set to be the c squared. Now we know 5 squared is 25. And we know 7 squared is 49. And we're going to check to see when we add them up, do we get this 81? Now, if I use the calculator to add 25 plus the 49, so I'm just doing a squared plus b squared, we actually get a 74 over here. And we know that 74 does not equal 81. So since a squared plus b squared does not equal c squared, no, we do not have a right triangle. Now, one thing I'm going to start to kind of sketch for you guys here is I'm going to let this side be the 5. Okay, this is going to be the 5. And if that length is 5, then 7's just a little bit longer than that. And I want you guys to see here that this c squared, see how c squared is too much, how 81 is too much? That means that this line is too long, which means we don't have a right triangle. And if we want these dimensions to kind of work out, what we must have here is a right, or sorry, not a right angle, an obtuse triangle. So I'll show you now that we have, this must be the 5. Again, this would have been the 5 and this would have been the 7, but we see here that 9 is too much. So we know we don't have a right triangle. But if this is the 5 and this is 7, then the thing that was too much, that longer side, can now kind of connect in here. That can be the 9. So we have an obtuse triangle right here. When the hypotenuse is too long, that must mean that these three sides form not a right triangle, but they form an obtuse triangle right here. Because again, if it's too long, for it to fit, I need to kind of angle this thing over a little bit. And now I've created an obtuse triangle. All right, for number 3, again, we have a 4 by 9 by 10, and we're just trying to see if that would form a right triangle. So we want to check to see, does 4 squared plus 9 squared equal 10 squared? Now we know 4 squared is 16, and 9 squared is an 81. And we want to check to see, would that equal the 100 that we get over here? Right here, this is going to be a 97. So once again, we can see that the hypotenuse over here, the 100, is too much. So no, these are not equal. No, we do not have a right triangle. And if I sketch this and let this be a 4, and we said that that would be a little too long, again, it's going to be an obtuse angle, not by much, but this would be the 9, this would be the 10, and we are going to have something a little bit bigger than the right angle. That must be an obtuse angle. So no, we do not have a right triangle here. No, it would not form a right triangle. Now for the last one, I just wanted you guys to see one with some decimals where you definitely need your calculators. So we're just checking here to see if the 22.5 squared plus 30 squared gives us a 37.5 squared. If yes, then we know these are the dimensions of a right triangle. If not, then no. So let's start out with the 22.5. We're going to square that. So 22.5 squared. So that's a 506.25. 506, oops, let me put this in green. 506.25. Okay. Now 30 squared is just 900. So we want to check to see if when we add that up, is it the same as the 37.5 squared? Since the 900 is already in my calculator, I'm just going to go ahead and add real quick the 506.25. So on this side, we get 1406.25. And we want to check to see now, does that equal this number squared? So the 37.5 squared, check it out. Yep, it's the same thing. That is the same thing. So that does equal 1406.25. And since they are the same, then yes, these are the dimensions of a right triangle. And if we were to sketch that, if this bottom one is the 22.5 length, and then the height has to be longer than that, it's a 30, and you can just see I'm sketching here, it's not perfect. And that means the longer side here, oh gosh, that looks so bad. I really can't do that, can I? Boom, here, and then here. All right, that one's not so bad. So 22.5 went here. The height was a 30, we said. And then the hypotenuse is in fact a 37.5. It does form a right triangle, so we are set. So yes. So I showed you guys what happens if it is true. You get equals on both sides. They equal the same number. And if they don't equal the same thing, it's not true. And chances are you're going to have an obtuse triangle here. All right, now let's take a look at these last two problems here. We're trying to use this page to verify the Pythagorean theorem. And we're checking to see if you really know what it means by a squared plus b squared equals c squared. Now you might remember in the visual proof that you guys watched a couple days ago about this showing the a squared plus b squared equals c squared. These sorts of things might look familiar when we talked about how the 3 squared plus the 4 squared equals 5 squared. That means that this 9 plus this 16 equaled that 25, and that's true because 9 plus 16 does equal 25. So now let's see if we have similar kind of pictures, if it in fact proves the Pythagorean theorem or not. So for this one right here, we have a 36, a 64, and a 100. And I want to know if given these square values, is this right here a right triangle, yes or no? And it looks like here, the answer is going to be yes, because if I do a squared, it doesn't matter what a is in my picture, but a squared is 36. It doesn't matter what the length here is because b squared is 64. And it doesn't matter here what c is. All I care about is what c squared is because I want to check to see, does a squared plus b squared equal c squared? And in this case, the 36 plus the 64 does equal the 100. And since 100 does equal 100, yes, we know that this right here proves the Pythagorean theorem. And I can take it a step further and get the dimensions, because if this is the side squared, then I know if it's 36, this has to be a 6, because 6 squared is 36. And right here, this has to be an 8, because 8 squared is 64. And I can say that this side has to be a 10, because 10 squared is the 100. So yes, right here, yes, we do have the right triangle. And the side lengths would be the 6, the 8, and the 10. And again, that's because 6 squared plus 8 squared does in fact equal 10 squared. All right, now when we come over here, again, it doesn't matter at the beginning of the problem what this side is, or this side, or this side, because I just want to know, does this side squared, the 4, plus this side squared, the 16, does it equal this side squared, which is a 25? So the answer here is actually going to be a no, and it's because 20 does not equal 25. If this is a 4, we know the side length has to be a 2 right here. This has to be a 2. And if this right here is a 16, this has to be a 4. And if this was a 25, that meant this had to be a 5. So if I had put 2, 4, and 5 listed out like I did up here, a 2, a 4, and a 5, that's exactly what you would be doing. You'd say, okay, does 2 squared plus 4 squared equal 5 squared? And you'd realize the answer is no. So this is not proving the Pythagorean theorem over here, because again, this 4 plus this 16, 20 does not equal the 25. So no, we do not have a right triangle here. And if I wanted a right triangle, what I would need to do is, let me actually see if I can get a gray pen to kind of match this. Let me just kind of gray that out real quick. If we kept the 4 and the 16, this would be a 20 right here. We need the 4 squared plus 16 squared. That would be right here, or 4 plus 16, that'd be a 20. So whatever the square root of 20 is would actually be this length right here. And let's see if we do the square root of 20. So that's going to round to a 4.8. So this would be a 4.8. And if it was a 4.8, then we have a right triangle. But the original problem as is was a no. Okay, the original problem as is was a no. What you guys are going to do now is you're going to flip over to the next page, and you've got some to try, just yes, no. And right here, I didn't include the part for you to circle yes or no, but you can just put the word yes or no next to each of these to see if they prove the Pythagorean theorem. Again, your answers for that will go into a Google form, and then you'll use the rest of the page to show any scratch work for the slides or the check for understanding. All right, thank you for watching today's video.